The earth beneath our feet feels solid, dependable, unchanging, but deep below the surface, far beyond where our eyes can see, something is stirring. Strange vibrations, known as deep earth tremors, are rumbling through the planet's core. Are these tremors a sign that the earth is shifting in ways we don't fully understand? Today, we're diving into the science behind these mysterious quakes, what they mean for our planet, and whether they could signal something bigger on the horizon. Let's start with the basics. What exactly are deep earth tremors? Unlike the earthquakes we typically hear about, which crack and shake the ground near the surface, deep earth tremors occur hundreds of kilometers below, in the Earth's mantle, or even deeper. These aren't your garden variety quakes, they're subtle, low-frequency vibrations that can last for hours, days, or even weeks. Scientists call them non-volcanic tremors because they don't seem to be tied to volcanic activity. Instead, they're often linked to the slow grinding of tectonic plates or fluid movements deep within the Earth. To understand why these tremors matter, we need to take a quick journey into the Earth's structure. Picture the planet as a giant, cosmic onion, layered with a thin crust, a thick mantle, an outer core of molten metal, and a solid inner core. The mantle, which sits between the crust and the outer core, is a hot, semi-solid layer of rock that flows slowly over millions of years. It's here in this dynamic zone where deep earth tremors often originate. The mantle is under immense pressure and heat, creating conditions where rock can deform, crack, or even partially melt. When these processes happen, they can send out faint seismic waves that we detect as tremors. So what causes these tremors? One leading theory points to something called slow slip events. These are like earthquakes in slow motion. Instead of a sudden jolt, tectonic plates slide past each other gradually, sometimes over days or weeks. This slow grinding can generate tremors that ripple through the mantle. Scientists have observed these events in places like the Cascadia subduction zone off the coast of the Pacific Northwest, where the Juan de Fuca plate is slowly diving beneath North America. The tremors there are so subtle that no one on the surface feels them, but they're picked up by sensitive seismometers deep underground. Another possible culprit? Fluids. Deep in the earth, water and other fluids can get trapped in rocks under extreme pressure. When these fluids move, say through tiny cracks or faults, they can trigger low-frequency tremors. It's a bit like the Earth's plumbing system springing a leak, sending vibrations through the surrounding rock. This idea is still being studied, but it's gaining traction as scientists uncover more evidence of water locked deep within the mantle. Now you might be wondering, are these tremors dangerous? The short answer is not directly. Unlike surface earthquakes, which can topple buildings and cause tsunamis, deep earth tremors are usually too weak to be felt. But here's where it gets interesting. They could be early warning signs. Some researchers believe that deep tremors might signal stress building up along fault lines, which could eventually lead to larger, more destructive earthquakes. In places like Japan, where tremors are common along subduction zones, scientists are closely monitoring them to see if they can predict when the next big quake might strike. Let's zoom out for a moment and consider the bigger picture. The Earth is a dynamic, living planet. Its tectonic plates are constantly shifting, its mantle is churning, and its core is spinning. Deep Earth tremors are a reminder of just how active our planet is. Some scientists even think these tremors could give us clues about the Earth's long-term evolution. For example, could they be linked to changes in the planet's magnetic field, which is generated by the movement of molten iron in the outer core? Or could they hint at shifts in the mantle's convection patterns which drive plate tectonics? These are big questions, and we're only beginning to scratch the surface. One fascinating area of research involves looking at deep tremors in places we wouldn't expect, like beneath stable continental interiors. For years, scientists thought tremors were mostly confined to subduction zones where plates collide, but recent studies have detected them in places like the central United States, far from any plate boundaries. This has led to speculation that the Earth's interior might be more dynamic than we thought, with hidden faults or fluid pathways triggering these mysterious vibrations. So, is the planet shifting? In a sense, it always is. The Earth is never truly still. Deep tremors are just one piece of the puzzle, a faint whisper from the planet's depths. They remind us that our world is alive, constantly reshaping itself in ways both subtle and dramatic. While they don't pose an immediate threat, they're a call to keep studying, to keep listening to the Earth's heartbeat. Because the more we learn about these tremors, the better we'll understand our planet's past, present, and future. As technology improves, we're getting better at detecting and analyzing these tremors. New networks of seismometers, some buried deep underground, are giving us unprecedented data. Machine learning is helping scientists sift through massive datasets to spot patterns that might have gone unnoticed. And who knows, maybe one day we'll crack the code of deep earth tremors and use them to predict earthquakes, monitor volcanic activity, or even uncover new secrets about the Earth's core. For now, deep earth tremors remain one of nature's great mysteries. They're a humbling reminder that our planet is far more complex than we can imagine. So the next time you feel the ground beneath your feet, take a moment to think about what's happening far below. The Earth is speaking, and it's up to us to listen.